Hi, today we're going to go through some of the questions and we're going to continue with our matrix algebra. And then today we're going to talk about how to calculate the determinant. And then I'm going to take up two examples from chapter 5 of the textbook. So first, why do we do a determinant? A matrix algebra determinant, which is, this is the symbol that has been used, is the matrix, like if A, let's say, is equal to 1, 5, 1, 0, 3, 9, minus 1, 0, 0. If this is matrix A is equal to this matrix, then to calculate the determinant, this is the symbol that we use to calculate the determinant. Now, determinant is usually used to solve equation such as Kramer rules, although other methods of solutions are computationally much more efficient. But determinants are used for defining the characteristics of polynomial of a matrix whose roots are the eigenvalue. So in geometry, the sign n-dimensional value of n-dimensional parallelepiped is expressed by the determinant. So this is used in calculus with exterior differential forms and the Jacobian determinants. So in particular for changes of variables in multiple integrals. So this particular examples that I just wrote it can be found on 5.1. So it's from 5.1 is chapter 5. So from chapter 5. Now, and this is of course it's for A of the question. So the question is asking, find the rank of each of these following. And then one of them, part A, is that's the matrix is giving, and then you're told to find the rank of this matrix. Now, we talk about the determinant, how we do the determinant, and then I'll go into the I'll do and find the rank of this equation. So to calculate the determinant, what we do is, this is first 3 column, 3 rows. So this is 3 by 3 matrix. And then what we do is just we write the matrix. So it's 1, 5, 1, 0, 3, 9, minus 1, 0, 0. So the traditional way that is being used to calculate this one, and similarly these textbooks that we are using for this class is using this one, is that we would cover one side, one row and one column, and then and then we take the determinant of this one. Of course, don't forget sign, so that's a plus, minus, plus. That's how we do it. So the determinant of this one is equal to 1 times 1 is the leading. So we cover those two, and then we write these two number. Then it's 3, 9, 0, 0. Now follow the sign, minus 5 times. You cover this and this. So we do this and this. And then what is left is 0, 9, minus 1, and 0. And then sign plus 1. And we cover this, and we have 0, 3, minus 1, and 0. So each time, the first one, you just want 1, and then the first row, and then block this 2 and take this number. And then this is how we calculate your determinant. So it's 1. This is how you multiply. 3, times 0 minus 0 times 9 minus 5 times 0 times 0 minus 1 times 9, and then plus 1, and we have 0 minus 1 times 3. So this is 0, whole thing, this is equals 0. Then it's 9 minus 45, because minus times minus is positive, and 1 times 9 is 9, and then it's multiplied by minus 5, that's minus 45. And also now we can write it's a positive times 1, so that's plus 3. 1 minus times minus is 1, that's a positive. Positive 1 times 3 is 3, and 3 times 1 is 3. Therefore, the result is minus 42. So the determinant of this matrix algebra is minus 42. Just to show you a shortcut, if you want to finding the rank of this matrix algebra, if the determinant of 3 by 3 matrix is non-zero, then directly you can make a determination that it's a rank 3. Means there is 3 zeros that they are non-zeros, 3 rows that they are non-zeros. And then if it's 0, then it could be 2 and 1. Then you have to do a what they call row reduction operation. So let's move to the next page. And then in the next page, we're gonna find the rank of this matrix that we just wrote before, and that is 1, 5, 1, 0, 3, 9, minus 1, 0, 0. So now we know, and then we're gonna use row reduction to determine the rank of this matrix. First of all, we're gonna interchange row 2 and row 3. We're gonna exchange those two. So we are exchange. So we're gonna exchange row 2 and row 3. If we do that, what is going to happen? So I'm going to do it step by step, an extra step so that you can follow. So row 1 stays the same, 1, 5, 1. And then we're going to exchange the 2, bring 3 to 2 and 2 to 3. So that is minus 1, 0, 0. And then we have 0, 3, 9. Probably now you know why we did this, because now you're seeing by adding these two, you will have a 0. So you, by finding a row, the rank of the matrix means that you have to do an operation and reduce these rows until you find that the entire row is 0. If we have this entire row is equal 0 and then 2 non-zero rows, then we can say that is the rank of this matrix is 2. And then if we have 2 of the rows, all zeros, then that means that we have a rank of this matrix to be 1. If we have no 0 rows, means all 3 of them, there's one of the coefficient is non-zero in each rows, that means that we have 3 non-zeros, and therefore the rank of this matrix is 3. So basically that's what we are doing. Now we have this one, and then what we do is just we take row 1 plus and add it to row 2. When we do that, what happens? Add those two. So we have row 1, you write row 1, and then row 2, you write 0, 5, 1, and we repeat row 3, and then put it the way it is. Now we are looking here, and then we can see that we have 5 here. So let us divide row 2 by 5. So when we divide row 2 by 5, so row 1 we're gonna repeat and then write it the way it is. Then we get 0, 1, 1 over 5. Then we get 0, 3, 9. Write row 3 the way it is. So now what we do is that we multiply the new row 2, which divided by 5, by -3. You know, the reason I do it for -3, and add the result to row 3. So what we do is that we multiply row 2 by 3. So multiply row 2 by -3, and result of this we add it to row 3. And what we will get is we have like 1, 5, 1, 0, 5, 1, and then we multiply this. So sorry, it's 1 over 5. 1 over 5. So now multiply this by 3 and add it to this. So if we do 0, because 3 times 0 plus 0, it makes no sense. Now we have 3 times minus 3 times 1 is -3, plus 3 is 0. Then we have -3 times 1, then this will be -3 over 5 plus 15 plus 9. So you will get 18 over 5. 18 over 5. So, or you can write this in some of the textbook. It's just written as 2 over 5, but it doesn't matter. It's the same. So you cannot basically now so actually, if you divide this by 1, then this is 1. So now, if you look at it, we cannot reduce this anymore, and then we stop here, and then we need to conclude by writing a statement, some sort of statement, something to the effect that to tell the reader or whoever is grading your midterm or final exam or an assignment that you know that the rank of this matrix is 3, and then also you should give just one statement and say, okay, the rank of matrix A is equal 3, and then you can say it's because there's 3 non-zero rows. So the rank of this matrix is 3. So that's the first part of the question. And then we're going to move to the second one. So part B of chapter 5, that's 5.1. So we have a matrix B, and again, that's 3 by 3 as well, 0, -1, -4, and we have 3, 1, 2, 6, 1, 0. So again, that's 3 by 3 matrix. Again, we are asked to determine the rank of B, matrix B. So that's the question that's been asked. Now, you can do it different ways, but the way that is being taught in the class and in this textbook is that we use a row reduction operation to determine the rank of this matrix. And the way we did it, you saw it in part A, we're gonna follow exactly the same thing. And then just by looking at it, with two rows we can arrange so that we can get as many zeros as possible in these rows to determine the rank of this matrix. First, we can say that we can interchange row 1 and 3. So let's start by interchanging row 1 and 3. So interchange row 1 and row 3. So matrix B becomes, so we're gonna bring 6, 1, 0, 3, 1, 2, and then we're gonna bring row 1, 0, -1, -4. So we need this to be 1. And therefore, the easy thing we can do is to divide this entire thing, the entire row, by -6. So divide row 1 by 6. So we get 1. 6 divided by 6 is 1. 1 over 6. And then 0 divided by 6 is 0. And we're going to repeat column and also row 2, 3, 1, 2, 0, -1, -4. Now, what we need to do, we can see we have 3 here, and then we have 1 here. So we multiply row 1 by -3, because if we need -3 and +3, this is going to give us 0 here. So we multiply row 1 by -3, and then we add it to row 2. So we write row 1, 1 over 6, 0. And now we multiply row 1 by 3, -3, and add it to row 2. Then -3 + 3 is 0. And then -3 over 6 plus 1, that is +1.5. And also we have 3 times -0 is 0, plus 2 give us 2. And we repeat row 3 and the way it's been written here. So 1 -4. So now, if you see here, we have 2 zeros, and then we have 1.5 and half and -4. So what do we need to do here so that we can get this row equal to 0? The simple thing is that we have 1, we have 4, and then we can multiply this row 2 by 2, multiply row 2 by 2, and then we add it to row 3. So you remember 1.5 and 2, and let's see what we get. So we get 1 over 6, and then we have 0. Row 2 was 0, 1.5, and 2. And then we say we're going to multiply this by 2 and add it to row 3. When we do that, that will become 0. So 1.5 times 2 is 1, plus minus 1 is 0. And then 2 times 2 is 4, plus minus 4 was here, then it's 0. Now we can see that the entire row is 0. And therefore we can say that the rank of matrix B is equal to 2. And the reason is because there is two non-zero rows. So this is what we will calculate and determine the rank of our matrix. So I'm gonna do one more determinant because I felt that we probably need one more example of how to calculate determinant, even though it's simple. But the thing is that I'm just gonna go a little bit in details and then explain. And by giving you an example, it's the easiest way to get the point across. So again, how to calculate the determinant. Let's say we have a 3 by 3 matrix, and that 3 by 3 matrix is 1, 6, 4, 2, 7, 3, and then let's say 8, 9, and 5. So this is the matrix, and again, 3 rows and 3 columns. So 3 rows and 3 columns, 1, 2, 3. So it's 1, 2, 3, 1, 2, and 3. So then we have 3 by 3. So 3 by 3, that rows times column. Now, again, as a determinant, we say is that usually what they do is that they block the paper on this side and on this row and on this column, and then take the determinant, calculate the determinant of what is left times the diagonal, the coefficient here. So the determinant of A is equal 1 times. So we're gonna cross this. Let's say so it's 1 times 7395. Again, don't forget, plus, minus, plus. And then we have the second one. So we have minus 6. So now what we're going to do, we're going to block this plus this. What we are left with is 2, 3, 8, and 5. So we have 2, 3, 8, and 5. So again, I say plus, minus, plus, then plus, and then now you can say cover it, block it, whatever is easy for you to understand. And this is what I mean. So now you take 4 times, and then these 2, so you have 2, 7, 2, 7, 8, and 9. So you have 2, 7, 8, and 9. Okay. So now is just cross multiplication, cross multiplying these. And then taking the product. And then you see what you get. So let's move to the next page. So for the first one, we had 1 times, we had 7, 3, 9, and 5. 7 times 5 minus 9.3. 9 times 3. That's the first one. Then we have minus 6. And then we had 2, 3, 8, and 5. Therefore, 2 times 5 . 2 times 5. So I don't like this one. So we had 6 times, sorry about the mess, 2 times 5. So that's 2 times 5 minus 8 times 3. And then we have plus 4 times, we had 2 times 9 minus 8 times 7. So here we have 7 times 5 is 35, and 9 times 3 is 27. And then it's minus 6. And then we do 10 minus 24, 8 times 3, and then plus 4, and then we have 2 times 9 is 18, and then 8 times 7 is 56. So we just go 17, 35 minus 27 is 8, and then minus 6 times, and then we have minus 14, and plus 4 times minus 38, because 18 minus 56 is minus 38. And then we have 8, and 6 times 14 is, because minus times minus is plus 84. And then we have 38 times 4, and that sign changes to minus. And that is 4 times 38 is 152. So just to add this one. So I hope that my addition and subtraction is right. And then if things are right, then we have a 8, and 84 is 92 minus 152. And therefore, this one is equal to minus 60. So the determinant of A is equal to minus 60, and this is how you calculate or determine the determinant of a matrix algebra. Now, also in chapter 5.4, and chapter 5.4, and then it's an exercise number 4. It's asking to find the inverse of each of the following matrix. I'm going to do only one. So, and I hope that you will do the rest and following the steps that I am going to be doing. So it's been giving as E, matrix E is equal to, so it's 4 minus 2, 1. It's 7, 3, 0, and then we have 2, 0, and 1. So that's what we are doing. Now, to find the inverse of matrix E, The first step is that we need to calculate the following. We have to need the determinant. Is the inverse of E is equal that 1 over the determinant of E times the adjacent of E. So we need to do this operation in order to determine the inverse of, which is the sign symbol inverse of E. So that's an inverse. Again, we have 3 by 3. Of course, the first things first, we need to do the determinant. So the determinant of E is equal to, again, block, row, and a column. Take what is there. And again, here, just one thing you should remember here when you do this operation. Before I say plus, minus, plus, then it will be minus, plus, minus, plus, minus, plus. So don't forget this, because that's going to make big changes. If you miss any of these signs, then your results will be wrong. And then you'll be trying and then not knowing that you need to follow these signs. So we have the first one, it's 4, and then cover this and this, and then what you have left with is 3, 0, 0, and 1. And then we have minus times minus, so it becomes 2 plus. And that's why I said minus and minus. When you just write it on the side, it helps you to see what sign here, because if you write minus 2 here, and then you try to multiply, and then by the matrices and the product of the matrices, your solution will be wrong. So what we do is we cover this, and then what we are left with 7, 0, 2, and 1. So it's 7, 0, 2, and 1. And then we have plus and plus here, nothing. And then cover, and then what we do is we left with 7, 3, and 2, 0. 7 and 3, and we have 2 and 0. So again, multiplying like this, what we get is 4 is 3 times 1 is 1, it's 3 times 1 is 3, minus 0, because 0 times 0 is 0. Then you have plus 2, and then you have 7 times minus 0, because 2 times 0 is 0, and then plus 1, and then 7 times 0 is 0, and then minus 2 times 3 is 6. So we have here 4 times 3 is 12, and then plus we have 2 times 7 is 14, and then 1 times minus 6 is minus 6, and therefore that is equal to, so 12 times 14 minus 6, it's going to be 20. Again, so it's, yeah, 12 times 14 minus 6, yeah, it's 20, yeah. So we found that the determinant of matrix E is equal to 20. So now we did this part. So that's the first step. So that's the first step, is that you determine the determinant of matrix 3 by 3. Now the second step is to find the adjacent of E. The simple thing is, the way that you can write is the following. Now what I wrote here there is plus minus plus minus plus minus plus minus plus. This becomes very handy. So we write 1/20, and this is the calculation of adjacent. So we have the first one, row, so we write the determinant. So it's 3, 0, 0, 1. Sign is plus. So again, we cover 4 and the first column, first row, and then we do the second column, second row, and then we do the third, and then that's how we follow. And then sign is minus, and then it's 7, 0, and 2, 1. And then it's plus, and we do 7, 3, and 2, and 0. So just on the side, let me do the matrix E. So matrix E is 3 by 3. So we have 4, have minus 2, 1, 7, 3, 0, 2, 0, 1. So you have plus, minus, plus, then you have minus, plus, minus, then you have plus, minus, plus. So what you do is that you cover the first one, it's 4, and then you take what is here, and then you cover 2. The reason I put it's 2 plus 2, it's because then it's minus 2, then becomes plus. So, and then we will do the same thing, like cover this, and then take minus 2 and 0 and 1, and then cover this. So that's how we do the operation. And then by doing this one, we have minus, it's minus 2, 1, 0, 1, and then it's plus 4, 1, 2, 1, and then it's minus 4, 4 minus 2, 4 minus 2, and 2, 0. Row 3, then we have plus, and it's minus 2, 1, 3, 0, and then we have minus 4, 1, 7, 0, and we have plus, and that's 4, minus 2, 7, and 3. So that's our matrix, and then now we do the operations same way when we calculate it or determine the the determinant. So it's equal to 1/20. So we have the first one is 3 minus 0, and then we have minus 7 minus 2, and then 0 minus 6, and we have minus 2 minus 0, and then 4 minus 2, and then minus 0 plus 4, and then we have minus 6. It's simple. And then the second one is 7, and then we have 26. So when we do further, then adjacent of E is equal to, so it should be 3 minus 5 minus 6, 2, 2 minus 4 minus 6, 7, 26. Now, the adjacent of E is equal to C transpose. And that is, the column becomes row and row becomes column. So adjacent of E is equal to C transpose. So we have 3 minus 5, 6. And we have 2 minus 4. And then we have minus 6, 7, 26. So to write the complete answer, the inverse of matrix E, which was given, is equal to 1 over 20 times the determinant of E multiplied by adjacent of E, which is 3, 2 minus 6, minus 5, 2, and 7, and 6 minus 4, 26. So we'll stop here. So that's how we calculate the inverse of this equation. Now, another problem from the textbook that I find it's very useful is chapter 5.4, and it is exercise number 6. And the question is asking, solve the system of AX equals to D by matrix inversion, by matrix inversion. So we have been given two equation, which is 4 times X plus 3Y, and that is equal to 28. And then we have 2X plus 5Y, and that is equal to 42. So what we're trying to do here is we're trying to change this into shape where X star is equal A inverse times D. And the way we do that is that we would take this matrix equation of AX is equal to D. So we take the AX equals to D, this matrix equation, and multiply both sides by A inverse, like A inverse. So we have AX, and then we multiply both sides by A minus 1 times AX equals to A inverse times D. So on this side, A inverse on this one becomes identity of X, and that is equal to A inverse times D. And from here, then we can write that X star is equal A inverse times D. So that's what is equal. Now, how can we write this equation, the two system of equation, in this fashion? So we have two arguments here, and these arguments are we have X and Y. And then if you put it more, if you elaborate it more and then put an economic test to it, and as I mentioned before, you can say that this is the price times quantity. And therefore, we have X and Y. These are two goods, and this is the coefficient, the number of goods that you can consume, and that's equal to 28, and that could be your M, which is your income. So it means that the combination of this good can be consumed subject to your income. So the way we write it here, so we say we have two arguments, is X and Y. So the inverse of this, the way we calculate the inverse of this inverse is equal to 1 over the determinant of this matrix A. And that is equal to 1 over the determinant. If you write it in terms of matrices, you can say that 4, 2, 3, and X is equal 1. And then, so that's 4 times 5. 4 times 5 minus 2 times 3. And therefore that is equal to 1 over 14. So the determinant is 1 over 14. Times, so the way you write it, A inverse 1 is equal, let's say if you have a matrix, let's say you have a matrix A, that's A, B, C, and D. And then when you try to find the inverse of A, that is equal to 1 over AD minus CB, and then times. Then you flip these two and change the sign of those. Then that becomes D A and becomes minus C and minus B. So that's the formula that you use. So you flip A and D and change the sign or switch the sign of B and C. So when we apply this to our matrix that we have, so we have A inverse is equal 1 over 14, and then we had a matrix which was 4, 3, 2, and 5. So the matrix that we had was 4, 3, 2, 5. So what we do is we flip those two and change the sign of those two. So we put 5 here and 4 here. Minus 3, minus 2. So that's what we do, and then that's multiplied by 28 and 42. So the question is that, are we done? The answer is no. We need to further calculate. Now, we need to get it in this form. Minus 1 times D. So that's the inverse, and that's the D. So what is our x's? We have X, we have Y. What's the inverse? It is, you can write it 1 over 14, 5 minus 3 minus 2 and 4, then multiply by 28 and 42. You can write this as 5 over 14 minus 3 over 14, and then you can say minus 1 over 7, because 2 over 14 is minus 1 over 7, and then we can have 14, and then we have 2 over 7, and that's multiply by 28 and 42, which is 30. Now, all we do is we take row multiply by column. You go this, and you go down. Doing this, so we get 2 by 1. So we have 2 by 2, and then you have 2 by 1. Matrix operation says that if the column of second one and the row, the first one and the row of the first one, the column of the first matrix and the row of the second one are equal, that means that you can do the operation. And what this 2 and 1 is telling you that you will get 2 by 1 matrix. I mean, whatever you get 2 by 1 matrix. That's what it means. So let's do an operation. Take multiply by 28 times 5. So 28 times 5 plus minus 13 over 4. So 5 over 14 times 28, and then it's minus, so it's plus, then we have minus 3 over 14 times 42. So that is equal to 10 minus 9. So we have 10 minus 9, and then for the second one we take this one and multiply it again here. So we have minus 1 over 7 multiplied by 28 plus 2 over 7 multiplied by 42, and therefore that is equal to, it's minus 4 plus 12. So minus 4 plus 12, therefore that is 1 and 8. So 2 times 1. So the answer is 1 and 8. So this is how you solve, means x is equal 1 and y is equal to 8. That's how you solve for the system of equation. And then now this one will bring us to the other part of our question, and that is that we comparative static analysis, and that is the really fun part of the equations that we do. And I'm going to do one of the questions, and then we're going to continue next time, and also speak about the comparative static in details. So we now move to chapter 6, and that is comparative static analysis. So comparative static analysis. Comparative static analysis, as the name suggests, is concerned with a comparison of a different equilibrium status that are associated with the different sets of values of a parameter and exogenous variable. For purpose of such a comparison, we always start by assuming a given initial equilibrium state. In the isolated market model for examples such as an initial equilibrium will be represented by a determinant price P, which is P star, and a corresponding quantity of Q. Similarly, in a simple national income model, the initial equilibrium will be specified by determinant of Y star and the corresponding C star. Now, if we let this equilibrating, changes occur in the model in the form of change in the value of some of the parameter or exogenous variable. So the initial equilibrium will, of course, be upset. As a result, the various endogenous variable must undergo certain adjustment. If it is assumed that a new equilibrium state relevant to the new value of the data can be defined and attained, then the question posed in the comparative static analysis is, how would the new equilibrium compare with the old? So that is the question that is answering. How would the new equilibrium compare with the old? So it should be noted that in a comparative static, we will still disregard the process of adjustment of the variable. We merely compare the initial percentage equilibrium state with the final post-change equilibrium state. Also, we still preclude the possibility of instability of equilibrium, for we assume that the new equilibrium to be attainable just as we do for the old one. So let's do an example, and that's going to make it much easier. So let's do question from section 6.2. We do exercise number 2. So the question is asking, or basically this section is dealing with the rate of change and the derivatives. So you're giving a function, and the function is y is equal to 5x squared minus 4x. And then it asks find the different quotient as a function of x. And I don't like delta x. I'll change the notation a little bit. It's much easier. So we can put it as f of x plus h minus f of x, and that divided by h. So that's much easier, and that is equal to change in y with respect to change in x. So first thing what we do is just wherever we see x, we just put x plus h, and then we expand and then see what we get. So let's say from here 5. So we have 5. Let's write it as so because we have 2x, x plus h, and x plus h, and then minus 4 times x plus h. So let's do this one. Let's do this operation first. So we have 5 times x squared plus 2xh plus h squared. I'm sure that you can do this one. And then minus 4x minus 4h. So this part of what we have, we can write this as a 5x squared plus 10xh plus 5h squared minus 4x minus 4h. So it means this whole thing is our f of x plus h. And now we're just going to do all this. We're going to subtract. So we have 5x squared plus 10xh plus 5h squared minus 4x minus 4h minus f of x minus the functions that we were given, 5x squared minus 4x, all of this divided by h. So now it's a matter of simplification. So we have 5x squared plus 10xh plus 5h squared minus 4x minus 4h, and then minus 5x squared plus 4x, and this whole thing divided by h. And now we collect the like terms. We have 5x squared plus and minus, so these two cancels. And then we have h here, and then we have h among these others. So we have 4 minus 4x plus 4x, this cancels as well. So what we are left with is 10xh plus 5h squared minus 4h divided by h. We have common factor of h, so you take h, we have 10x plus 5h minus 4 divided by h. H and h cancels. Therefore, we have 10x plus 5. In the textbook, h is denoted as dx minus 4. So that's your answer for this question. Again, thank you, and I hope to see you next week.